Okay, so this is the packet tracer, or this is the skills integration challenge for Chapter 8. It deals mainly with subnetting and IP addressing. This goes for IPv4 and IPv6. They typically follow the same rules. You can see here we've got the 4 hosts. One needs 500 hosts, one needs 250 hosts, and then you have the IPv6 network. Those are going to be assigned the 16th IP address for their subnet. We're going to start with branch A. I've already started with some of the subnetting. I can't do all of it, but I'm going to show you how to do one of the more simple subnets. So this is how subnetting works. You have binary. You have 128. You have 64. 32. You have 16, 8, 4, 2, and 1. Each bit in a byte represents one of these values. They in total they add up to 255. Or 255 different combinations of bits. So you can use these to make, or this is what the basis of IP addressing in IPv4 is based on. So to start, we have, I've got an IP address of 172.20.18.0. So this can be broken down into 4 different bytes. This will be 172, which is 1010 1100. So that means that there is 128, 0 64s, 132, 0 16s, 18, 14, 02s, and 01s. So that's the basics for how binary works. I'm going to do it for the rest of the IP address. So you have 20, which would be 0, 0, 0, 0. Oh, actually. 1, 0, 1, 0, 0. The next one would be 18, so 0, 0, 0, 1, 0, 0, 1, 0. And then you'll have the last value, which will be 0 because it fills none of the binary values. So that is 172.20.18.0 converted into binary. This is where I'm going to actually start explaining subnetting. So you have the value, the standard value for subnetting. It's the default most of the time is 255.255.255.0. And 255 is actually every one of these binary values filled up. So there would be a 1 here, 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 all the way down, all 8 values. And so that can be, so this is a system which is, it decides how many host values are available in each IP address. These are the networking bits for, okay, in this case you'd have 8 bits here, 8 bits here, 8 bits here, 8 bits here. That would mean that out of these 3 bits, or bytes that are taken up, that means 8 of these bytes will be taken up as network values. However, that leaves 8 values here for host networking, and that would be 255 hosts or IP addresses available, not hosts, because host would be 2 minus that, because you have to factor in the broadcast IP address and the and the network address. So this is translated into 1, 1, 1 all the way down. So IPv4 uses a AND rule when determining subnets. So you'll see that for subnetting, you actually you use an AND rule. So if the IP address and the subnet have a 1 in the same position, you carry it down because this and this have a 1. Because both of them don't have a 1 right here on the second bit, that means it would carry down into a 0. So you keep going until the first, this will give you the network address. This is the very first IP address in that subnet. This means that this is the very first, this is sort of the name given to that network. You use this to figure out the first and last usable IP address on a network. Also, after this, you get the, from this you can figure out the broadcast address, which is the last IP address available on that network name. So here, because with this, you'll see that every one of these values are filled up. You would fill up every value left in the every value on the network that isn't used. Every value. So you have the 255, 255, 255. .0. That means every one of these values cannot be touched. But when you're trying to figure out the last usable IP address, you are going to see that you have the IPs over here. You're going to fill up every value inside this spot. So that will end up becoming a 255 in this case, but in some cases where you have maybe a 252 IP or final subnet value. So say that this was a 252. That would mean that you could use up to, or that means that every value from 128, 64, 32, 16, 8, 4 are all used, and that leaves these 2 bits to be used for host networking. This is a really small network. This is just an example. So to use this in our case, we're going to need to know that because of that value, we will only be using these last zeros for the broadcast. So you'll have the same string, which will be 1 0 1 0 1 1 0 0 dot 0 0 0, etc., until you finish. And you're brought down with this last octet. So you're going to take that, and you're going to say, because we have 0 values left in the subnet to AND or with it, we're going to have a 1 or a 255 value there, because there are no subnet values in that area, or there is no subnet values in that octet. So you're going to that's going to end up becoming a 255 just because of common knowledge. Just if you practice this a lot, it starts to become more apparent. But just common knowledge, you'll end up just remembering that that'll be 255. So you'll see in translating this, you'll have, because of the binary values up to their current value, you're going to see that you have a 172.20.18.0 as the network value, and you'll have a 172.20.18.255 as the broadcast. These are not supposed to be used by your hosts, which would be like computers, printers, stuff like that. They're not supposed to be touched. They're the first and last, and because of that, they're isolated from what you would normally use. This is just standard stuff you would do in a network. So we're going to take these values. You're going to see that, well, you add 1 onto this because you need the first IP address. So you would see that your first usable IP address would be 172.20.18.1, and your last usable will be 172.20.18.254, because the broadcast is the last or the last IP address. You need the last usable, so that'll be a 254. And so we're going to take that, and we're going to start configuring these switches and routers. So you have to make a few networks with this. I'm going to start with the hosts, actually, because it's just simpler to explain. So you'll see that for PCA, you need the IP address. You'll see that I'm putting 172.20.17.254. This is from one of the other networks that I configured before this, because it would take too long for me to subnet it right here. So you then it comes the subnet mask, which would be 255.255.255. Oh, sorry, it's a 254 actually. .0. Next, you're going to configure the default gateway. We can't do that yet because that is actually the connection this PC has to, or this host has to this router, and that connection isn't available yet. So I'll come back to that later. But you're going to see for PC A2, we're going to use the IP address we just got from that last one. So 172.20.18.254, because we are going to be using the last usable or last usable host address for the hosts. So this will be a 255.255.255.0, and like I said, I'll go back to the default gateway. And now I'm going to configure the router. This is just mostly practice. I'm going to go through the basics. This will include host names, banners, line configuration, passwords, basic security stuff. So I'm going to start with the host name. So you use the command hostname, and you're gonna use the host name which is given. For this case, it's going to be branch A. And as you can see right here, you can see that the branch or the host name changed. Now I'm going to go on to the banner, which is going to be the message that pops up when you enter the computer or enter the configuration. So this will be unauthorized access. It doesn't really matter what you put here for now, because this isn't a real simulation, or this isn't a real router. This is just a simulation, so no one else is going to see it. For this case, I'm just going to put unauthorized access. And as you can see, if you go back, when you enter in again, it'll have the unauthorized access banner come up. So I'm going to head back in. Now there's going to be a few things I'm going to have to do. So to put a password, there's going to be two levels of passwords. There's going to be one to get into user exec, and there's going to be one to actually access the router. User exec is a privilege that you get that you have to set on the router. So I'm going to use enable secret, and in this case the password is going to be class. Next I'm going to use service password encryption. This will mean that all passwords that I can view through the show running config command will not show up in clear text. Sorry, wrong privilege. And as you can see, this is where the password for enable secret would have been. It's not in clear text because of the service password encryption. So it is using some sort of hash. I haven't really configured anything else. You can see the banner right here and the host name. So I'm going to move on to configuring the line console. So I'm going to go to line console 0, and I'm going to change the password to access the router to Cisco. You also have to use the login or enable login command, which is simply login, and you can exit from there. And that means that now there is a login password. So now if I type Cisco, I'm now able to enter. And if I press enable to get into a higher privilege, then I also am confronted with the class password. So now I'm going to enter the line VTY 0 through 15 lines. Now I'm going to do the same thing with the password here. Cisco, login. And now I'm going to enter the interfaces. So I'm going to use interface gigabit 00. This is the actual connection. So you can see here the connection here is gigabit 00. That's which port that this Ethernet is connected to on this router. So that would be going out to the PC A1. So I'm going to put an IP address on this. So I'm going to put IP address 172.20.17.254. And you have to put the the subnet address after this, because otherwise it won't know how to divide the network up. So I'm going to use 255.255.255.25. Oh, it's 254.0. Sorry, 255.255.255.0. So now that I've enabled, or now that I have a address configured, now I have to enable it. So no shutdown. Now that the interface state is changed to up, now I can actually access, and you'll see up here that this this connection has become green. It is now able to communicate with PC A1. Now I'm going to go and I'm going to interface with PC A2. So interface gigabit ether or 01, IP address 172.20.18.254, and use the subnet of 255.255.255.0. You use the no shutdown command, and now that is established up here. Now the last one I'm going to configure on this router is the connection to the central network. We don't actually touch this in the packet tracer unless we're specifically told to. It's basically another one of these networks, but it's separate, so we don't touch it. So interface gigabit Ethernet 0 or gigabit Ethernet 02, IP address 172.20.31.254. 255.255.255.252. Now this is a different IP address because it's not one of these two. It's different because it connects to the central network. The no shutdown command. And now that should be up and running. I can exit this router. And now I'm going to go on to branch B. This is the IPv6 network. This is a little bit more tricky. It uses the same idea as IPv4, but on a little bit, you have to get used to it. It's a little bit more difficult at first. So IPv6, I'm going to configure the host addresses. For this one, it'll be 2001 DB8 fade FF 10. And then you always have to make sure to use the slash whatever number, because that is it serves the same role as the subnet in IPv4. It tells you what values are available for the host. The link local address is how it connects to the router as well as the gateway address. This one is going to be a FE80B. The gateway will be as well. And I'll come back to the DNS server in a second. Now I'm going to do the same thing with B2. It'll be 2001 DB8 fade 100 10, and the slash will be 64. Like I said, I did subnet some of this stuff beforehand because it's difficult to do it all at once. It'll take way too much time to get within a 30-minute block, so you're not seeing everything I've done beforehand. I did set up most of these networks, or I have all these networks IP addresses written down beforehand. I'm reading it off a piece of paper. So onto the branch B. I'm going to enable, and I'm going to start by changing the host name again. So this will be branch B. The banner message of the day will be unauthorized access. The password, which will be enable secret, will be class. Enable the service password encryption. And now I'm going to move on to line console. So this password will be Cisco, like the last one. This is just to make it simple. If you configure a different one for each time on a practice packet tracer, it can be a pain, so I'm keeping it simple for this demonstration. Now I'm going to go on to line VTY015 and change or make a password that is called Cisco. That is for the it's how a router is connected to over a network. And so what's going to happen is you can use your PC. You can enable a password through VLAN and stuff like that. VLAN is so you enable another password, and it allows you to, or you enable another IP address on the router, and it allows you to connect to it and or you're able to connect to it instead of using a console connection. This is sort of fake right now, because you would actually have a console cable connected It's not allowed on here. But you'd have a console cable connected between a host, like a PC, and the router, and that's how you'd be connecting to it. What this allows is for you to once you set it up with the console cable, you can disconnect the console cable and use it and connect to it through that IP address. So I'm going to move on to the interfaces now. So interface G00. The IP use different. You're going to have to use different commands for IPv6 as opposed to IPv4 because the router needs to know that you are using a different system. So in this case, it'll be 2001 DB8 fade FF1/64. I forgot a word in there. And now you have to enable it again. And you can see the state has been changed to up. You can add descriptions and stuff like that to each network if you want to organize it better. Like I said, I'm trying to be fast. So I'm configuring the connection between branch B and PCB2. This will be 2001 DB8 fade 100/64. Do the no shutdown. That is changed to up, and now for the last interface on branch B will be the interface G0/2. IPv6 address 2001 DB8 FFFF2/64. I'm getting this IP address or this IPv6 address from here. I wasn't actually supposed to create this network from branch A to central, branch B to central. This was given to me. So enable that. That has been configured, and now I can go on to changing the DNS and default gateways on here. I actually do realize that I screwed up on something, and I did use the wrong IP addresses for branch A, so I'm going to have to go back and configure that. And this is why you need to know the passwords, and it's just better to have simple passwords on a practice. So I'm going to go to interface G00, IP address 172.20.16.1, 255.255.254.0. No shutdown, just to make sure that something doesn't happen along the line. It's just better to do this now. I can go back into interface G01, do the same thing, 172.1 or .20.16 or actually it's 18.1, 255.255.255.0. No shutdown. And now on to the final thank you. Interface G02, IP address 172.20.31.254. This will be a 255.255. .255.252, another example of one of those networks I was talking about earlier. No shutdown. And now I'm going to go back. Something that I did mess up on was the branch name. Wrong privilege again. There we go. The host name is now spelled correctly. Now to configure the default gateway. The default gateway is the IP address that the router has to that connection. So you can see that the router here is connected on G00. So that means that I'm going to be using the G00 address as the default gateway. So that was a 172.20.16.1. Now the default gateway, I'm supposed to configure it from here. This is the DNS server. So I'm going to be connecting to it through this IP, the given IP addresses. So this will be a 172.20.32.10. So I'm going to do the same thing for PCA2. I have to reconfigure the IP address, so it's 172.20.18.254. The subnet will be 255.255.255.0. Default gateway is 172.20.18.1. And the DNS server will be the same as PCA1. It'll be 172.20.32.10. Now on to PC, B1, and B2. So they use the exact same, or they use the same style. I'm just going to connect to it, connect to the DNS server using the given IP address. So it's 2001 DB8 fade 1010. And on to PCB2. It's going to be the same thing. It's going to be 2001 DB8 fade 1010. And there we go. I apparently didn't do everything, so I'm going to use a few troubleshooting techniques. So here we go. I'm going to try pinging from PCA1 to PCA2 and see if I can reach it. So PCA2 is the address 172.20.18.254. Now you just have to wait if it okay, so it's able to connect to PCA2. That means there isn't a problem between PCA, the router, and A2. So now I'm going to try and ping from PCA1 to to branch B. I'll do PCB1. So ping 2001 DB8 FADE 00FF slash it was fade FF 10. It's pinging right now. Okay, it looks like the connection didn't make. So now I have to figure out where it went wrong. So I'm guessing it happened somewhere between branch A and branch B. So I'm going to use a trace route to that IP address. So I'm just going to go back, change the ping to trace RT. trace RT, and it will give me a good idea of where the problem is occurring. Okay, that didn't work. I'm just going to go through and check my branch A configuration. So that show running config command that I showed you earlier, this is where it becomes useful. So I'm going to use show running config, and I'm going to look specifically at the interface addresses. So I can see on Gigabit Ethernet 00, that would be PCA, is configured 172.20.16.1. So I'm going to check, and that is the correct IP address. Now onto 01. It should be in 18.1. And onto 02, it is the correct address. So now I'm going to move on to PCB, or branch B, and see if it was over there. So show running config, and you can see I've got the IP addresses right here. They're configured with IPv6, that is to be noticed. So I've got for Gigabit Ethernet 00, which is right here, I believe. Yes, right here, it's a PC1. So that would mean that the address is supposed to be a 2001 DB8 fade FF ::1/64. That is correct. For Ethernet 01, that is supposed to be a 2001 DB8 fade 100::1/64. That is correct. For Gigabit Ethernet 02, that is a 2001 DB8 FF 4 Fs and then ::2/64. So that is correct as well. Now I'm going to go on and check my my addresses on the PCs to make sure that I did in fact get that right. So I'm going to check here, and PCB1 is supposed to be 2001 DB8 fade FF ::10 with a /64 subnet. The link local address is correct, so is the gateway address, and the DNS server shouldn't matter in this situation because it's not connecting between PCA and PC1, or PCA1 and PCB1, so it doesn't actually connect to central DNS server. So now I'm going to check at PCB2. You'll see 2001 DB8 fade 100::10/64. The link local is correct, as well as the IPv6, or the IPv6 gateway is correct as well, and the DNS doesn't matter in this situation. So now it looks like I maybe have not connected, or not have configured . So in this case, I'm going to use a little cheat right now. So because I'm running out of time, I'm going to use assessment items, and I'm going to see that I actually did not use the correct link local for Gigabit Ethernet 00 on branch B for any of the interfaces. And the DNS server IP address, or IPv6 address for PCB2 wasn't working correct, or wasn't correct as well. So I'll have to fix the link local addresses. I believe they would be, or I'd have to double check, but I'll start with the PCB2. I'm almost done, so I don't think I'm going to be able to get it done in time actually, because I've only got 3 minutes. So B2, the address for the central server, it should be a 1000, not 100. And for the ports here, I need to use the interface G00. Oh yeah, I didn't configure it. So IPv6 FE80 : B, and put the command link local afterwards. Oh, I forgot to use address. Yes, that was the correct one. And you just use that same command for the other three, and that should give me the perfect 75. I'm only off by 2 points. And that's all I have to show you. Oh. So actually, I'm gonna try and do it real fast while I can. Interface G01, IPv6 address FE80B. And the last interface G02, and that'll be IPv6 address FE80 : B link local. And as you can see, I've got the perfect score at the bottom right corner. And so that is all I can show you for now. I've got to go. Yep, it's a perfect score. Thank you for watching.